Whenever we have problems like this is actually what we call a Hess's law problem. And the reason why I know that is because we have many reactions, and the only thing we need to do is we've got one goal reaction. And the goal then is to calculate the delta H, or that enthalpy value, for this given reaction. And we know all of this stuff. So what we're going to do is we're going to add and potentially multiply and maybe even reverse some of these reactions in order to get this. So in doing so, we're just going to work our way from left to right. So first of all, I say I need a carbon. And in all of these reactions, there's only one of them that has that carbon. So what I'm going to go ahead and do is I'm just going to rewrite this first reaction, because I need one carbon on the left, and this reaction, just as I've written it, has that one carbon on the left. So a slow start, but so far so good. Then the next thing I see is I need 2 hydrogens. So I'm again going to look through all of my different reactions. There's only one reaction that has hydrogen in it, but when you look at this, you notice that I need 2, and on the left, I only have 1 here. It's on the correct side. So what I am going to do is I'm going to multiply everything here by 2, because I want this coefficient to match. So this coefficient needs to be the same. So then as I copy this, I'm just going to copy it with the multiplication. So I'm going to have then 2 hydrogen, this is as a gas, plus 2 times a half is just 1. So there's my oxygen. And now this is going to yield 2 waters as a liquid. And then here, I'm going to extend that 2 to my delta H value. So all I'm going to do is multiply 2 times this as well. So that multiplication extends to the value of delta H. So again, since I've done that multiplying by 2 across everything, as long as I've included that delta H value, everything should look just fine. So lastly, so at this point, I can actually add these 2 things together and see where I'm at. But frankly, I like to go ahead and see and make sure I actually have all the pieces I need. So I'm still missing this methane, and in all the reactions I have, only one of them has methane. And if my stoichiometry looks good, I need 1, I have 1, but it's on the wrong side. So I am going to go ahead and reverse this. So all I'm going to do is put all of my products on the reactant side, all of my reactants on the product side. When I do that, this delta H value, because I reversed my reaction, this delta H value, I need to change the sign. So this delta H now is going to be a positive value. It was originally negative, but because I reversed the reaction, I need to change the sign of my enthalpy value. Now, we're going to add everything together. And as we do this to me was always one of the most fun parts, because we get to cross out anything that's the same on both sides. So as we're going, here is a carbon dioxide, and here's a carbon dioxide. And these do need to have my arrows all nice and lined up. They're not as lined up as they could be, but these need to be on opposite sides of those reaction arrows for this to work. So my carbon dioxides will cancel out. My 2 waters will also cancel out. My methane does not cancel. That's good. I wanted to keep that. And I've got 2 oxygens here, and I have 1 here and 1 here. And so we could have canceled those out individually, but again, since I've got 2 oxygens here and 2 oxygens there, those also cancel. So as far as all of this is concerned, I'm just going to keep whatever's left over. These should be the things that are unique that are only on one side or the other of that reaction arrow. And then for my delta H values, I'm just going to add these all together. So that's actually what was happening here, was I was just adding them all together. And that's all I'm going to do here. Everything is all added together, just straight addition. I should have this, and my units were in kilojoules per mole. So I hope that gives you a better notion of Hess's law. I do think it's clearer to have everything lined up and do this cancellation. Sometimes you may see something that looks a little bit different, which is going from this having all of my reactions together. Some people will go ahead and write everything out so that then you can see everything on both sides of the reaction arrow all in one line. So there is technically another way to do this. I don't know that it's actually clearer, but in case you were curious, you have options. I can't quite get this all on one page. Oh, yes I can. Just barely. Just barely. Oh, it's way over there. And again, I have that same general idea where I have my reaction arrow here in the middle. So there's my arrow. And now again, anything that's the same on both sides, I can get rid of. So just like they were spectator ions, I can get rid of them. And there's my oxygen, and here's my oxygens. So we should be left with that same answer. But again, some people just like to write things in different ways. And again, the more important part here is that ability to just add together all of your enthalpy values, because we added together all of our chemical reactions. So since we added all of our chemical reactions, all we're going to do is add together our values of enthalpy.